Good morning, everyone, and thanks for joining us for another Azure Security Clinic. And today we're going to be talking about multi-cloud security with Azure Sentinel and MITRE ATT&CK. So I'm David McKenzie, I'm Head of Managed Services at Quorum Cyber, and joining me this morning will be Matt Erasmus, one of our senior analysts. So today we're going to talk about clouds and signals, threat intelligence, hunting, analytics, more signals, and Weebles. So between Matt and I, we're going to attempt all the demo gods and attempt to do live demos of actual signal ingestion, monitoring, alerting, everything. So first up, let's consider the Azure Sentinel is a Microsoft theme. And a question we quite often come across is the, oh, but I have insert cloud provider of choice. AWS is obviously one of the common one, Google Compute, Bluemix from Oracle. Everyone will kind of have, you know, a kind of random piece of infrastructure that somebody spun up in another cloud. And they say, well, does that mean Azure Sentinels for me? The answer is yes. Ultimately, these things are all just signals, and signals are the bread and butter, the what we want to do with our theme. So first up, let's take like arguably one of the biggest competitors to Azure is AWS. So Matt is going to give us a quick run through of some of the stuff that we can do straight off the bat with Azure Sentinel consuming AWS. Matt?
So we have an AWS console with an account set up. And what we want to do is we want to connect this first into Azure Sentinel so we can get those signals going in. This is super easy, it takes about 5 minutes of your time. The thing that does take time is the waiting for the ingestion to start taking place because we are ingesting CloudTrail data, that does take a while to come through, anything from 5 to 15 minutes. So to start off, we're going to head over to our Azure Sentinel data connectors, and we're going to need these two secret pieces of information, the Microsoft ID, which I'm sharing with you now, and the external ID, and we're going to create an IAM role. So we head over to the IAM console, we head over to our roles, and we're going to create a new role and plug in that information. I've already done that just to save a bit of time. I have my role here, which I've created. We're attaching the CloudTrail read-only access policy to that because we just want to be able to ingest those logs. We don't need to do anything other than that. So you create your role, you plug in those two bits and pieces, role on here, you copy that, and you bring it back and you paste it into your role to add here. You click on add, and you'll eventually see down the bottom here that your role has been added, and then after a few minutes you will see, and let's just open up another console here. Am I in the right one? Give it a couple of seconds. Connect this page, and we will see it'll look something like this. So you've got two roles here, and they're receiving data. So if you go back to our Sentinel workspaces, you'll start seeing stuff coming in, which is great. A whole bunch of scary alerts over the evening. This was just me playing around, nothing to be too worried about. But with that data coming in, we can now start querying the logs and doing all sorts of fun stuff. So to begin with, you can start doing touch bigger so we can see it a bit better, and we'll get rid of those because we don't need them. So the log you want to query is the AWS CloudTrail log, and if we just query this with a simple KQL query with no fancy stuff, you will get a big scary log after a while. And let's just bring this up a bit more, of all the CloudTrail events that have happened in that AWS account over the last, in my case, 24 hours. Let's just drop that down to an hour so it's not quite so scary. And you'll see all the data coming through, and then you can start running queries on that data to figure out what's going on in the environment. So for instance, show me all the console logins for IAM users. So we'll run that, and we'll get, let's move that up a bit, 16 answers to that. So this is me logging in this morning to make sure that all my demo stuff is still working. And that is that. You can also then go, and I'll need to change that to 24 hours, show me all the AWS instances that have been spun up. So if we can actually just drop this down to show a bit more detail. You can see that yesterday at 10 to 5 in the afternoon, a user CloudGoat has spun up an instance in US East 1, and this is the source IP address. So you can very quickly start digging into what's happening in your AWS environment, which is kind of nice. But we don't really want to be sitting here and looking at this sort of stuff. We want to be like pulling in this data and sifting through it and alerting on things that could be a bit suspicious or potentially malicious. And that's where hunting comes in, and your Azure Analytics. They do have quite a few built in. If you head down to your analytics and we change the type, not the run type, there's a whole bunch of them. But what I found is most useful is sort of coming up with my own scenarios and then building alerts based on that. For instance, I know that IAM users should be changing their policies. And we can see here in incident 1927 that we have a user that has updated a policy version. So that to me is a bit suspicious. So if we click on that and we give it a couple of seconds and we go to full details, you'll get a page that looks like this. And we've got a MITRE attack of privilege escalation. So this could be a user trying to escalate their privileges up from a lesser privileged user up to perhaps admin. We've got 11 events associated with that and 1 alert. So the easiest thing for me, and this is how my workflow tends to work, is I'll go into the alert. Okay, when did this happen? We've got the display name of it, a brief description, and we can see that this happened yesterday at around 7:53 p.m. So in our environment, users working after hours isn't that typical. So this to me is already a bit suspicious. We've got a user that is changing policies after hours. So let's dig into the finer detail on that. And as I slowly, painfully scroll across the left-hand side of the screen, drop that down and drop down the extend properties. This is the long way of getting to this. I'm doing this just to show you the sort of the full picture, and there are easier ways to get to this, but I could then copy that query out, dump it in here, run that, and then these are all the queries where a user has changed their policy version. So okay, we've got a particular user here. Okay, I know that that's a dev user in our environment. So what have they exactly done? And if you can actually then dig into the detail of it, we can see that this user has changed in the request parameters here, they've changed their policy attached to their user account to version 5. At this point, I'd be like, okay, what exactly is this user doing and what policy is attached? You would then go into the IAM access, the IAM roles, and use the IAM console. You could then go to that particular user and we could have a quick look at that policy that has been attached. Have a look at the JSON because that's better. And that is a terrible policy. You can actually go back and dig through those policies. I won't go through that now. It's a bit outside of the scope of this discussion. But this here is a terrible policy simply because it allows everything on everything. So this is effectively giving this user here admin access, and that to me is terrifying. So what we've got here is a Sentinel alert from AWS telling us that this user has modified their policy and escalated their privileges up to an admin user account. This user can then create users, delete users, and do pretty much anything. What tends to happen is that user will then see what else they can do, and what usually happens is they will then spin up a whole bunch of super big EC2 instances to mine Bitcoin for as long as they can, and give you a big scary bill in the morning. Thankfully, we picked this up via Sentinel. We are able to go, okay, this is the user, and then we can then would do is I would go to that user and just log into that user's thingy and give it a couple of seconds. And I would kill the user's access keys immediately. And the console password is disabled. They don't have the thing, and so because we've killed the access keys, they don't have a console password set. There's no way for them to log into AWS now. So we've effectively very quickly remediated that based off one alert. So if you go back to our big scary incident list, and you'll get all the common things. For instance, logging in without MFA. There are a number of tools that will do this sort of thing for you. The login without MFA is one of the built-in ones. So that very quickly allows you to have a look at which users are, logging into your AWS console without MFA enabled. Here we see a login from my home IP. And we can go to the full details here. And again, go the long way around just to show what it looks like. We've got a login from, go across to the side here. I suspect this is me logging in from home. I need a bigger mouse. And again, just take out the query here, open up a second query window, and we can have a deep dive into this. We've got a federated user, and this would be the console login for this user. Again, this is probably the user has adjusted their policy to give them admin rights, created a new access key, and then logged in without MFA. So this is then related to the IAM policy version change here. So change the policy, seeing that they've got more access, create a second set of access keys, which they can then use to log into the AWS console and wreak havoc on everything going on in there. So here we have the example of a user started an EC2 instance. We can go into this. And this could be related to our suspicious login above. And again, we can see the MITRE attacks of there'll be an impact here, and we've got execution of code, or of, in our case, an EC2 instance being fired up. And this is just a custom rule that I created, because I know that in our environment we have a particular user that will always fire up EC2 instances. We use Terraform to deploy stuff that is tied off to a specific user. So all you need to do is just create a simple rule to say if an EC2 instance is started up by anyone but this user, trigger off an alert. So just copy out that query. This is kind of what the query looks like. I haven't done the not in this case. I've just locked it down to a specific user, but the end result is the same. But these are all the EC2 instances that have been fired up by this particular user in our particular time frame. So this alert would be raised, and you would be able to see that, okay, we've got a naughty user starting EC2 instances up in a particular region. You could then go and investigate that and find out, is it legitimate use or is it not? In this particular case, it is not. It's not particularly useful. It's not particularly legitimate, and yeah, you can then go and shut down those instances, and then perhaps log into the console, go to your users, and then go to your credentials, and then kill those access keys so that user cannot then continue to wreak havoc in your environment. Okay, so that's just doing some very basic and quick checks on alerts and the like. So these are with excuse me, pre-made queries that I've created. The quick way to go ahead and do this is you could open up the hunting console and start creating your queries here. But what I tend to do is I tend to open up my log analytics workspace and start playing with some queries, just to see if the data we get back is useful. So what I'm going to do here is, here's the very, very scary login without MFA query. I'm just going to dump that in there, and that looks good. Let's take that out because that's not valid KQL. And we're just going to run that. And we can see we've got a login there. So we have a login here from our malicious Raynor user. We want to create a custom alert for this because we want to find out when that happens. So we could just simply click alert rule. We want to create a Sentinel alert. And then you would just go through the very quick alert creation process. I won't go through that now. It's very, very straightforward. You'll add in your initial access and perhaps persistence, MITRE tags here, and all the other bits and pieces. I won't go through that now. I don't think it's particularly necessary. Okay, but what you end up with is your nice little analytics rule that looks like. Hopefully, I can find it. Log into AWS console with. Can I bring this out? But no, I cannot. But you get your little alert, and then that will then look at your AWS logs coming into Sentinel every however long you configured it. What I tend to do with this is I have the alert looking at the logs every hour, looking at 2 hours worth of data to try and catch that sort of thing. But you can adjust that according to your needs. So that kind of covers off on what you can do with the raw AWS logs, and that's sort of the management plane of AWS coming into Sentinel. What you can do with, for instance, EC2 instances and stuff running in your AWS cloud is you can run agents, and they can either be the Microsoft OMS agent, and get those logs getting pushed into Sentinel that way. Another thing you can do if that's not your liking is there's a very nice open source tool called OSEC, and what OSEC is a host-based intrusion detection system, and that very handily logs. You can configure that to log all its data in Ceph format, and Sentinel will quite happily ingest Ceph formatted data, so we can actually then look in our logs for that Ceph formatted data, and then let's just get that down and that down. Common security log limit 100. And all I'm doing here is I'm showing the last 100 entries for our common security log. And here we have the OSEC agent running on one of our hosts, and this is just monitoring all the happenings on that particular Linux host, and then reporting them into our Sentinel console. So what this allows you to do then is you can then create hunting queries or simple alerts on those bits and pieces coming in. So as an example, close that. But you can then create custom alerts on, for instance, you want to find out if a user has failed the SU password. That shouldn't happen all that often, but it does. Or perhaps you have a secret file on a particular server that you want to monitor for changes. What I would typically monitor here, being an AWS environment, is my AWS credentials file in a particular user's home folder, if that's something that you do in your deployments. So I won't go into the setup of this on the OSEC side, but all this equates to is, no, not that one. I want that one. I want to have full details. Go the long way. And we'll just run this query. So on that particular EC2 instance, I have this super secret file here being monitored. So a bad guy has logged into this host and changed this passwords file, and that has surfaced as an OSEC alert, which has been pushed through to Azure Sentinel for us to take a look at. So we can just run that, and we can see on the 22nd at around 2 p.m. in the afternoon, the integrity changed for this file. So then I would know that something has happened on that particular host at that time, and then I would start spinning up my incident response processes and logging into the box and seeing what has happened to that particular machine. Another thing you can do is, for instance, if you have a particular user or group of users that you don't expect to be logging in, you can then surface that again. Login from suspicious user. Drop that down. Extend that out. And I've just, for clarity's sake, I've just trimmed it down a bit because I know this is me logging in from home, but you could simply leave that out, take that out and run that. And you would see all the logins for, okay, we have a login for our suspicious user Ubuntu. Why is this person logging in? It's just a deployment user. It shouldn't be logged into, certainly not from a remote IP. And then again, you would see this alert would be surfaced in your Azure Sentinel workspace. And then you could then see that alert, great, something bad has happened, spin up your incident response process, and then start spinning up people and finding out exactly what went wrong there. And that's just another way of surfacing stuff from other cloud tenancies into your Azure workspace. And as Dave mentioned in the start of this, all this really means is that we don't, as the Sentinel workspace, we don't care what is coming in. It's all a signal, and we'll just ingest that, and you can then alert on that and action it accordingly. And I think that will cover off on all my use cases that I have. These are just a few of the use cases. It's really comes down to what you as a company expect to see and don't expect to see, and then just creating simple alerts on that in your Sentinel workspaces to alert and trigger off when those events are seen within Sentinel. It's really not difficult to get them done. There's loads of great examples of it on the Azure Sentinel GitHub. There's also the pre-built-in ones are also very good. For instance, the monitor AWS credential abuse or hijacking. This one was triggered when I was playing around with the other users' role elevation. So that triggered because I created access keys. They didn't expect me to create access keys via the CLI. So this built-in alert was then triggered. Sorry, this built-in alert was then triggered, without me having to do any work at all. So you often find that you'll have multiple alerts triggering if you're creating your own alerts, but at the end of the day, it's all very good telemetry to find out what's going in your cloud environments. I think with that, I shall hand it back to Dave.
Cool. Thanks very much, Matt. So that's the AWS cloud, and ultimately, every cloud, every computer, every application is ultimately just a signal. So the Sentinel is a seam. It aggregates things. The better you feed it, the better it is. There's an element of if your end cloud has the ability to analyze its own traffic, or the firewall has the ability to analyze its own traffic and create alerts, you want to consume those alerts primarily. You then want to sit there and say, right, does that raw data behind it give me extra ability to do extra queries and stuff in Sentinel? But ultimately, the care and feeding of your signals are the main kind of priority in your engineering a lot of the time. So you do need to make sure that you get your signals right. The cloud is as the adage says, just somebody else's computer. So ultimately, what you're looking at is the output from another computer somewhere or an application somewhere. So even AWS and all its complexity ultimately is showing you a bunch of logs, and those logs could be coming out of a really simple application or an absolute beast, which is AWS and all the marvelous things it can do. It's exactly the same for Google Cloud, for Bluemix, for any of these other cloud providers. If you're running infrastructure on there, then ultimately you're probably going to want to put the Azure Security Center agent on and get the telemetry from that infrastructure. If it is if it's a platform as a service and you want to get the underlying data about the platform, then you ingest that. So while we're kind of talking about signals, then that kind of leads us into the other kind of point that we wanted to discuss is, and Matt mentioned it a couple of times, but it's about MITRE ATT&CK. So I don't want to spend a massive amount of time looking at what MITRE is, but let's have a look and see what it is in terms of how we use it in Sentinel and how we think about it and use it in our kind of daily SOC life. So if we look at a number of different places, we will see MITRE smattered about in Azure Sentinel. So if we look at analytics, your rules and stuff, you'll see that the tactics are here, and our tactics are showing this is about credential access, this one is about discovery. And when we're looking hunting, we can actually see that we've got an entire raft up here of MITRE ATT&CK tactics. So if we look at lateral movement, so lateral movement is when an attacker's made his way into your environment and he wants to look about inside your network, move about until he finds something good to attack. Maybe he's mapping out things using discovery to figure out exactly how he wants to drop ransomware and moving about to try and get to high value targets. So the way you would think to commonly do that would be things like hosts with new logons. So hang on a second, there's a server that this person doesn't normally log on to. So we could go and run an analysis of every host with new logons. Now we're not necessarily going to create an alert off the back of this. This is hunting. This is where we're looking for things that are suspicious, but the odds are we're going to get lots of false positives. But we're looking for new and unusual things. But we might also sit there and say, hey, we've got all of a sudden that person's workstation is RDP into that person's workstation. Now, in a normal office environment, it's not common for users to remote desktop between each other. In fact, there's an argument for you probably should block it in Windows firewalls and stuff. But we can sit there and look for the hang on a second, here is, and if we look at that, we can have a quick look at the query. It's actually looking straight at behavioral analytics and saying, hey, let's go and pick up stuff that's unusual. But we could also sit there and say, show me every RDP session and average it and then figure out if there's anything new. So that's MITRE ATT&CK, and if we click on that, we'll just see the license that is MITRE ATT&CK. So it's not particularly the thing, it's just saying Microsoft has licensed it. But what we can do is go and have a look at MITRE ATT&CK itself. So let's bring that screen on. This is MITRE ATT&CK. So if we look at that, we go, right, okay, this is a mass of information. What is it we're actually looking at? What MITRE ATT&CK actually is a giant repository of tactics and techniques used by bad guys and grouped into who they are and the different tactics and stuff. So if we were thinking, right, I want to worry about particular groups looking after me, using some sort of threat modeling, then I could do it in here. Similarly, we can sit and say, right, I'm really worried about lateral movement. Okay, so how is lateral movement dealt with? And so we can sit and say, like, well, there's like internal spear phishing and things like that. We do remote services. Well, what does that mean? There we are, we have remote services, and there's like 6 sub-techniques of that. And when we look at that, we said, oh, look, there's that remote desktop protocol we were talking about a minute ago. So what's that? And then you say, right, okay, this is a simple explanation that this is what's happening. A list of all the different people. So these are like hacking groups that use this sort of stuff and attacks that use this. And all the way down at the bottom here, you can actually get a list of useful mitigations as well. So things that you can do to limit this or remove it from your environment. So MFA obviously stops people RDPing when they shouldn't, when they only just have a single password. Network segmentation, setting firewalls, making sure you're auditing all this stuff. Turning RDP off if you don't actually need it stops the bad guy being able to use it. So when we look at this and we've got all our extra details, that means we're sitting on, right, okay, we can see exactly what we should be worrying about. And that allows us to figure out exactly, well, what signals do I need to be bringing in, and what does that signal need to be showing me, and what do I need to worry about in that signal? So ultimately, this entire matrix is a giant repository of incredibly useful information that you want to worry about. So if we sit there and go, right, okay, let's go and look at account discovery. So account discovery, I'm interested in how are people mapping out my individual accounts inside my network. So this is bad guy's got in and now he's looking to find what your admin accounts are called and things like that. So we can sit and say, right, okay, there's the simple DOS commands in there of net user, and these are things that Defender ATP will pick up as suspicious, and you can write custom rules in it as well if you just want to do it purely in Azure Sentinel if you're not using Defender ATP, but you can sit and pull this stuff up. And then we can sit and say, well, who uses this stuff? Well, there's Bankshot. So Bankshot's an application, and it's been around, like it says there, since 2017, and the Lazarus group uses it. So we can sit there and say, right, okay, there's a Lazarus group, okay, and then this is an entire little history of who they are, what they do, and the sort of organizations that they go after. So we can sit there and go, who are they related to, and things like that. So we can sit and scroll through all of these bits of information and who they are. So if we pick another group, let's go down to Fin6. Where have they gone? I've lost them. If we go and look at any one of these groups, let's search for somebody. Fin6. Oh, well. So Fin6, ITG8, we can sit there and say, right, they are a group that are all about stealing payment cards. And if we are running a kind of brick and mortar retailer, then that's possibly something we want to worry about. They're kind of related to this group, and if we go and look at that group, we can actually go and get an analysis written by someone that actually tells you exactly what they do, how they do it, and these are normally really good security reports by reputable companies that everybody trusts, sort of thing. So you can actually take that and go and analyze it. So if I was running shops and had point of sales, then I could sit there and say, right, okay, these are things that I need to worry about. So I need to worry about them getting into my network and doing this. They look after they look after my archives and doing things like that. They tend to add stuff to my boot logons. So I need to make sure that when I threat model and say this group is interested in me, these are all the things that they do. So I need to make sure that if I want to build an alert on this stuff, that I have the signal that tells me that this is happening. So this is a massive resource. The tactics around exploitation and impact and stuff are things that Sentinel allows you to kind of group and classify on, and it tends to be you'll have an initial vector, and you obviously want to try and catch it there, but you also want to make sure you're looking for things like exfiltration and command and control, because you're not always necessarily going to see how they got in, but if you can catch them doing something, it's all about reducing that kind of dwell time on and making sure you know exactly what's going on. One of the other nice things that we can do when we're doing like a threat model is, if we now know what groups that we're worried about, we can take this. So what this is the attack navigator. And we can expand the sub techniques, but it makes it super big, so we'll keep that down just now. But what we can do is actually start picking groups or software that I'm particularly worried about, or mitigations that I want to say, hey, if I do this particular Active Directory, what will that make go away? So if we scroll down, let's pick APT1, like, okay, we've decided in our threat model and things that APT1 is interested in our business. So we can select that, and we actually get a little kind of highlight in all the boxes. It's not massively visible, especially on this, but if we do this, now we've said APT1, and I've now got a kind of graphical representation of all the stuff that I need to worry about. And I can then expand the sub techniques and say, right, APT1 come after things. What I can do is keep adding the other groups that have been identified as something that I need to worry about. So APT28 also might come after me, and what I'll do is I'll color them in yellow. Now we've got yellow and red in a lot of the same place, but when we can expand, we'll kind of see that in this huge thing. What this allows me to do is, if I am designing a SOC and a SIEM, to know which signals are the ones I need to prioritize, I can do a threat model and say, your type of business does this and needs to worry about these sorts of people coming after you. I now have a list of the people and the tools that they use, and now have an entire list of, right, okay, these are all the individual things that these people are known to do. I need to make sure that I've got a signal coming in for every single one of these things. So I am really interested, because the groups that are coming after me, they like to do spear phishing. So actually, to increase the security of my entire environment, I want to make sure that I can pick up spear phishing emails and block as many of them as possible before they even get into my environment. I also think, well, okay, well, I need to go and encourage all my senior managers and people with access to money and systems. They all maybe need slightly better protection than the other ones, because a lot of spear phishing is going to be attributed to against these people. So let's go and make sure that we have the signals coming in, but we have as many layers of protection against these individual things as possible. So that's how I can use MITRE ATT&CK and threat modeling to work out how I get, like, how I worry about which signals I go and get. If I've got a log for absolutely every single device on my network and in my environment, do I need to consume all of them into my SIEM? No. What I want to do is prioritize and make sure that I've got the logs, and that those logs coming in for all these individual things are as robust as possible, have been tuned to make sure I'm getting the right information. So there's little point in consuming a firewall log that has 100 million lines an hour if I only need 3 of them, because there's a config problem on firewall. So I go and fix the firewall before I consume that signal, and I've got a much tidier and neater signal. It's much cleaner. And then I can analyze that, and I can sit and say, right, okay, I am getting that if somebody does this command, I know that all my systems will pick up the result of that command being typed in, and the end result will be detected as it's been run. So simple example about signal ingestion. So we've kind of talked about MITRE, and we've kind of talked about like AWS and cloud, and that everything's just a signal. Azure Sentinel consumes signals, and essentially we can consume anything. So if we want to look at a silly example, so I am in the Weeble industry, and if you're too young to know what Weebles are, you can go and Google it. But essentially, I've done some threat modeling, and MITRE tells me that the group Anona Weeble likes to attack the entire Weeble industry. And I know that they like to infiltrate and put fake Weebles into my environment, and they like to try and steal my Weebles, and they like to try and knock my Weebles down. Completely insane and silly example, but how do I take an entire platform that is completely unique to me, that there's very few people doing it, so there's no built-in connectors, and I now sit there and go, but is Azure Sentinel for me? Because I've got this entirely custom application over here that's monitoring my Weebles. Nobody else is doing it, so I'm not going to have giant corporations come along and build me all these connectors by myself. Can I get my Weebles protected by Azure Sentinel? Obviously, given the fact this is a demo about Azure Sentinel, the answer is yes. So my Weeble application has a Weeble monitor. It's a SaaS platform, and it outputs JSON on demand, if you like. And the JSON looks like this. So every now and again, I get an output that says, here's my Weebles, it's from the app Weebles, and what the status is. So obviously, you know, some of them are up, some of them are wobbling, and Jenkins is down. So at this point, I'm saying, okay, this is coming, this I want to feed into Sentinel, and I'm going to worry about things. So one of the things I want to worry about is denial of service, the impact tactic. So I want to worry about when my Weebles are down. If my Weebles go missing, I want to know about it. And if a fake Weeble or an evil Weeble appears, I want to know about it as well. So the answer to all of this is a 5-minute connector. I'm going to build my own connector, and I'm going to bring it in, and we're going to analyze the results. I'm going to have a dashboard, and I'm going to be detected in near real time when anybody touches my Weebles. So I have made a logic app. So this is, plug it. It's like drag and drop programming in Azure, in the Azure platform. And what my app does is really straightforward. It's got arguably 3 steps. And all it does is I say, hey, this app listens. I don't have to go and configure anything in there. I literally just say, I want something to listen. And I gave it my JSON by literally cutting and pasting my JSON into a window. And it said, hey, this is what your schema is. So I went off and worked out all my schema, which is nice and straightforward and easy. And I don't need to worry about any of that. And it then says for every single Weeble it finds in that JSON, it's going to send the data to a log called custom listener. Now, that's it. That is enough that if I prod that with this JSON, it will appear in Sentinel. Simple as that. Technically it appears in log analytics, but my Sentinel log analytics. So for demo purposes, that is the curl command to poke a bit of JSON at that workflow. That URL there is the thing that is being generated by Azure for me. I don't need to do anything. I literally clicked on there and paste it into my window. When I do that, it sends that file to Azure to be consumed by Azure Sentinel. So that just went in. Let's make a fake Weeble. Let's save me typing. I already did it. So my bad guy has broken into my environment, and he has implemented a fake Weeble. I save my JSON file, and so my Weeble monitor has detected it, and I literally send it to Sentinel. So this might be in a kind of like SaaS application, you go into settings and say send my logs to, and you give it this URL. In our simplistic example, that's it. That app is running. I can actually see it running. So point to note, if you ever use Logic apps in production, then you monitor the Logic app running. It's a simple tick box at the end when you create the Logic app, but you always want to make sure that if you're going to rely on this as part of your infrastructure, that when these fail, which I managed to make it fail like once the other night, that gets picked up and investigated, because what you don't want to do is presume that your data is coming in without any issue, without that being monitored. So what does that look like? So that data appeared in my custom listener custom log. And that was literally from that connection where I sat there and said, send the data to custom listener. There it's there. When I run it, I'm only interested in my Weeble apps, so I could send lots of different things into my one custom log, but we can do that. And when we look at the time generated, we can actually see there are my Weebles coming in, the different Weebles of their status and the time they came in. So the data is coming in. In terms of what we're doing then in Sentinel, right? So if we do Sentinel, I currently have 14 alerts. Let's have a quick look and see if any of them are the new one that just came in. No, it's not run. They're running every 5 minutes. So we'll let that thingy. Our analytics. We have a Weeble monitor, an infiltration detection, and an abduction. And we can actually see that we've tagged them with the tactics that MITRE tell me they are, so that I can easily find them and I understand ultimately what the result of that being. This is a Weeble abduction. We didn't remove anybody from that list, but it is literally saying, hey, in the last 24 hours, these are my list of Weebles. In the last 15 minutes, I compare my list. Is there any missing? My infiltration detection, again, is literally looking back over a day of data and saying, hey, is there anybody just added that wasn't there before? So if we edit that one, because when we edit, it'll immediately make it go and run. We can actually see there's my tactics. So we've decided that this is about initial access and persistence. Yes, we've managed to make it into the environment and created something that allows us to stay in the environment, the fake Weeble. Our logic is literally just the query that we ran, and we've sat and said, hey, the host is going to be the name of the Weeble that's appeared is what I want to say. This is the one I want to worry about. I'm running every 5 minutes, looking at a day's worth of data so that I have some things to look at. I'm going to create an incident. I'm not grouping related alerts. I could. It's normally a good idea to group related alerts, but we're not doing it in this case. And we're not going to run any automated response. So I could write another logic app that goes back to my platform and say, delete that new Weeble and actually pass it in. We're not going to do it. We're just going to do review and save. That should be enough to kick off in a couple of seconds. Oh, come on. You know you want to. Right, while we wait on that stuff doing, we can say, right, okay, what else can I do with that data that was coming in? Well, actually, I have some nice AWS ones to have a look at my AWS user activities and stuff, and a nice little dashboard over there. I've created a Weeble workbook, so I've actually created my own custom dashboard to worry about my Weeble data. And when we go and look at that, we can actually get a nice graph of here's the data coming in about my Weebles from this data source and the exact number of kind of like broken down by how often are each Weeble coming in. So I can create as complicated a dashboard here as I like. It can have multiple panes and tabs. You can have stuff that appears and disappears depending on what the data actually looks like. It's quite a nice dashboard. The way we use workbooks in a SOC environment is if I got a Weeble alert of any description, I could jump into the workbook for that data to then just eyeball it and say, hey, look, straight off the bat, look, there's a new color on that one. Now that's something we just go, right, okay, yeah, I mean, if I had something alerting me, just going in there and saying, hey, look, there's something new just arrived that wasn't there before. sometimes you'll see, especially in things like Office 365 signaling, you can suddenly see that one user's doing something a lot more than they normally do. And so again, graphs suddenly get bigger in places. So workbooks allow you to visualize the data in a really nice way, that even if you don't know which user's the problem, so you might have had, hey, I've got an alert saying many more emails than normal have gone out, but it hasn't told you which user for some reason. You can go in and actually get a feel for what the environment is and what the data is. And so working on workbooks and giving yourself a good visualization of data is a really useful thing to do. Right, what are the odds that we've had our new incidents appear? They've not, that's typical. 11:28, Weeble Wobble monitors appeared. So our Weeble Wobble monitor is telling us that, yep, Weeble Jenkins has actually fallen down. And we can then go and say, all right, show me other events related to Weeble Jenkins, and we can get the raw data and go and get every single one of these Weeble things, but we can also sit there and say, right, okay, click on it there, and it'll actually go and spin it out into the graphical environment, and we can kind of move it about and say, right, okay, quite often Weeble Jenkins seems to trigger the fact that things happen to our Weeble. So he's related in a lot of wobbling going down, and he's been mentioned in some infiltrations when he first got added, fair enough, and he was mentioned in the abductions when he's gone missing in the past. So Weeble Jenkins does not seem the most stable of Weebles. Very annoyed by new ones, but let's have a look and see if we can. Weeble abduction. So if a Weeble went missing, we can sit and say, all right, okay, we used to have a Weeble called Julia who's no longer getting reported on. So we can immediately go and investigate that. Weeble infiltration detection. Oh, there's one. So a fake Weeble was injected. So that new fake Weeble is done. Now, if we had extra information coming in about telemetry or actions being performed by this entity, this host, then we can actually then keep expanding and keep going out. As it is, this is a very super simplistic example. So we're sitting saying, yeah, a new Weeble was injected into our environment. And with, oh, there he is. He's finally appeared just in the nick of time. Nope, it's still processing the data then. Let's view fuel details. So we have had a Weeble infiltrate us, and the fake Weeble has appeared in our environment. And we can, again, go and do the alert ID, go in and actually run it, and then say, hey, there's that. There's the entities detailed in here. We can go and get the actual query that was run at the time. Do a little thing in there, exactly the same way Matt was doing earlier on with AWS. And we can pull out extra information. Ultimately, it's a very simple query to make sure that we are literally just looking for stuff that's appeared that wasn't there before. And with that, that was ingesting a completely custom source that was made this week on the web without an ounce of programming or anything. The hardest thing was literally finding that Windows and the curl command uses an alias to PowerShell, so you got weird errors and you had to put curl.exe instead of thing. Setting this up for any application, whether this is a push, this was something listening, and we basically had a listener, it's sitting there listening for data coming in. Similarly, we could have run it on a timer and say, go forth and get that. So we could go and read an S3 bucket if we had an AWS application that was logging out to an S3 bucket. If we had a massive amount of data in AWS, you could use you could actually import straight into a data lake. 99.999% of the time, you're not going to do that. But ultimately, we're looking at it saying, right, we've managed to take a random application and pull it all the way into Sentinel after getting information from it that said, hey, we need to worry about this sort of thing because MITRE ATT&CK has told us that this group likes to do these things against this platform, and so we can go and check it. So that's the end of the demo. The recording will go up in a few days of the session, and if there's any extra questions come in afterwards, then we'll attach them to the YouTube channel and make sure we get them answered. But thanks very much, everyone, for your time.